Okay, Bhusan, yes, yeah, that's correct. I will send today. I will send today. Yes, 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 absolutely. So I will send today. So I will send today means what? Let's see. I am creating the what? Just hold on. Very good. Yes, yes. So let me save day 3. And what I am doing guys, right now I am sharing this in the day 3. Yes, it is open already. So just I think customer demo. No, no, not customer demo. Employee demo. Employee demo was the second program. This was the second program, guys. This was the second program. Day 2. This was the second program. So here I am going to paste, and today I will share what day 2 also. Okay, now today I will share day 2 also. Yes. Okay. So I am just giving you here, and today I will share day 2 also. First, you tell me, everyone understood heap and stack diagram? Can I proceed one more program today? Are you guys are ready? Come on. So I have pasted already day 2. Okay, now? Yes. Thank you. Thank you. Okay, guys, excited for the heap and stack diagram program? Come on, all of you. Thank you. Thank you. Thank you. Thank you. Thank you. So let's begin. Today, also very interested. Two programs I will discuss today. Very, very important programs based on the heap and stack diagram. Okay, now based on the heap and stack diagram. Already I have pasted in day 2. Okay, and maybe it I will post in what in the next text file also. Okay, now. So let's see. Day 3, one more heap and stack diagram program. Very, very important program. So let's say heap and stack diagram program on. This is very, very important. You will enjoy this program. Okay, very, very important. Look. So first you look at the overview of this program. So it is a test.java. It is a test.java. So first let me go here and let me write heap and stack diagram program on test.java. Heap and stack diagram program on test.java. Heap and stack diagram program on test.java. Okay. As usual, here we have what? One heap memory. And here we have what? Stack memory. Two more programs I will tell you, and one program I will give you as a homework. Okay, now? Two more programs I will teach you today, and one program I will give you as a homework. So try to complete. Now, look, heap and stack diagram. If you look at the overview, all of you, if you look at the overview of the program, what is the overview? You can see public class test. Public class test, you can see in this test class, we have two non-static field. Okay, now we have two non-static field. Public class test, we have two non-static field. What are those two non-static field? One non-static field is T, another non-static field is val. But T is a reference variable and val is a primitive variable. T is a reference variable. You know, reference variable will directly hold the value. And what is val? Val is a primitive variable. Primitive variable will hold the value. Reference variable will hold the address. Then two non-static field. One is primitive, another one is reference. Here we have a parameterized constructor. Here we have a parameterized constructor. By using this parameterized constructor, we are going to initialize these two fields. Oh, sorry. We are going to initialize only one field. We are going to initialize only val variable. This T is not initializing. Guys, please don't confuse. So we are going to initialize only one field val. This T field, we are not initializing through through this constructor. Then here you can see you have one more constructor. It is called constructor overloading. It is constructor overloading concept. And by using this constructor, you can see we are going to override both the non-static field. And there is no constructor chaining here. It is constructor overloading because from one constructor, you are not calling to another constructor. Tell me up to here clear? These 3 points clear? Write in the chat window so I can proceed. Come on, come on, come on, everyone. This program is very extraordinary program. I want response from all of you. Please write in the chat window. Very good. Excellent. So, guys, two non-static field. This constructor is initializing only this val, that is primitive variable. And this parameterized constructor is going to initialize both the non-static field. Both the non-static field is going to initialize through this parameterized constructor. And here you have a main method. Here you have a main method. In this main method, you are creating 4 objects. We will see one by one. Total 4 objects. You are creating total 4 objects. And here you have something. Here you have something you can see T2.t is equal to T3, T3.t is equal to T4, T1.t is equal to Tt.t, and T2.t is equal to T4.t, and then you have a SOP statement. So let's create heap and stack diagram for this particular program. So our program execution will start from main method and args, my first parameter variable. But as I told you, if you don't take command line argument, this is not active. So args is basically null. Then here you have first local reference variable T1. T1 is a local reference variable. In this T1, you are creating the object of test. So relax. I'm going to create the object for test. Where I will create the object? Come on, come on. Where I will create the object? First, let me do the formalities. What is the formalities here? Main underscore stack. Come on, everyone. Where I need to create the object? Come on, come on. Where we need to create the object? Come on, write in the chat window. Only 2 or 3 people are giving the answer. You just write only single word, H. So we need to create the object in the heap memory. So in the heap memory, I'm going to create the object. Look. (1000x). 1000x. In this 1000x, guys, in this 1000x, what object we are going to assign? Look, relax. We are going to assign this test object and we are passing the value 100. So first you create test object. So here, test object, take it in black color. Test object we are creating. Guys, in the test object, how many non-static field? In this test object, you can say you have total 2 non-static field, T and val. So you are going to write T and you are going to write val. Both the non-static field will get the memory. Okay. Now if you go, you can see you are passing here 100, line number 19. You are passing 100. That 100 will assign to this val. This 100 will assign to this val. And with the help of this parameter variable, you are going to initialize your non-static field. Your parameter variable name and your non-static field, both are same. And it is comes under variable shadowing concept, variable shadow. So to recognize my non-static field here, this keyword is required. To recognize my non-static field, this keyword is required. So by using this val, I'm initializing my non-static field. So this non-static field val value will become 100. Val value becomes 100. Okay. What about this T? Sir, T I have not initialized, sir. So once you have not initialized T, then it will get the default value. What is the default value? Null. Any reference variable, what is the default value? Null. Any reference variable, what is the default value? Null. Null is the default value. Okay. Then this object what you created, that object you are going to store one reference variable T1 of type test. So this T1 is the reference variable. So where this T1 reference variable will be created? Look here. T1 is your reference variable, and this T1 is pointing to 1000x memory location. T1 is pointing to 1000x memory location. Okay, great. Then you move forward. Move. Look, you are creating another object. Test T2 is equal to new test. It is very, very important program. You will understand the complexity of this program. Please keep patience, learn carefully. Test T2 is equal to new test. As usual, another new test, another object will be created and it is referred by T2. So of course, T2 will point to 2000x memory location. So what I am trying to do, I am writing here T2 will point to 2000x memory location. T2 will point to 2000x memory location. And in 2000x memory location, Bhushan, you need to clear your object-oriented programming concept. Okay, now you need to clear your object-oriented programming concept. Any non-static field, if you are not going to initialize, it is taking null. Any non-static field, I think you are confusing here why it is taking null. It is taking null because it is a non-static field. Any non-static field, if you don't initialize with user value, then it is null. Any non-static field, if you don't initialize with user value, then it is taking default value. Default value. Now T is what? T is a reference variable. T is a reference variable. T is a reference variable. Look at here. T is a reference variable. Once it is a reference variable, what is the default value? Null. Okay. Anyhow. So now I am going to create this second object. Okay. Second object. Then T2. T2 is pointing to this particular memory location. So here what will happen? This object will be created at 2000x memory location. This object is pointing to 1000x memory location. This object is created at 2000x memory location. Okay. In 2000x memory location, one new test object will be created. Look, 2000x new test object will be created. Whenever test object will be created, what is the universal truth? T will initialize and val will initialize. Initially with the default value. Initially with the default value, then you will see whether you are providing the user value or not. So what user value you are providing? You are providing 2 and T1. Then tell me, all of you, 200 and T1 you are providing. It will call first constructor or it will call second constructor? Just write 1, 2. First constructor or second constructor? Quick, 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 all of you. Very good. So Arnav and Sai, if you are not understanding, there is no use of what learning that much of depth knowledge. Okay. Sir, you are passing two value, 200 and T1. 200 and T1 means it will call first one or second one. Of course, it will call second constructor. So this 200 will initialize to this val and this T will initialize with what? This T1. It is something like copy constructor. You are moving almost what? Very, very closer to copy constructor. You are very, very closer to copy constructor. Look. So now 200 and T1. 200 will assign to this val. So directly what will be the val value? The val value will be 200 because it is primitive. Because it is primitive. So directly you will assign the value. Val is going to hold value 200. What about this T, sir? Sir, in this T, you are assigning T1. Hello. In this T, we are assigning T1. Then tell me, T1 is pointing to which memory location? 1000x memory location. So this 1000x memory location you are going to assign on this T. This 1000x memory location you are going to assign on this T. That means this T will point to 1000x memory location. Tell me, is it clear to all of you? Then I can proceed further. Is it clear to all of you? Then only I can proceed further. Very good. Excellent. Excellent. So no need to repeat. Actually, all the concepts are like that only. All the concepts are like or that only. You please try to concentrate. And you can understand if you have attended my last class. If you have not attended my last class, then first you watch that video, then you come here. Test T3 is equal to new test. Again, you are creating one more object. Test T3 is equal to new test. Then this test T3 is equal to new test. It will be created at 3000x memory location. T3 will point to 3000x memory location. So let's create here T3 will point to 3000x memory location. Then tell me, in 3000x memory location, what will happen? One more test object will be created. 3000x, one more test object will be created. Whenever this test object will be created, universal truth, what? T and val will initialize with default value first. T and null. T and val will initialize with default value. T will initialize with what? Null. Val will initialize with 0. Then what you are passing? You are passing 300 and T1. You are passing 300 and T1. Now you tell me, this 300 value will assign to this val. Are you agree? Are you agree? Prashad, I will share the link. After this class, I will share the link. Then you can see all the videos. So this 300 value will assign to this val. And this T1 will assign to this T. This 300 will assign to this val. And this T1. T1 is nothing but 1000x. It will assign to T. So what you can write? You can write val is holding 300. And since T is holding T1, and T1 is what? T1 is 1000x. Like that. Great. Okay, sir. Okay, sir. Now you can see the last object you are creating, what? T4. So definitely T4 will point to 4000x. T4 will point to 4000x. Let's say create here 4000x memory location. Look. So just I have copied 4000x memory location, test object, and whenever test object will be created, T and val will initialize. Initially default value, then later user value with the help of constructor. Okay. So what you are doing in this fourth one? In the fourth one, you are passing 400 and T2. 400 and T2. 400. So where 400 will go? Here 400 will come. And T2. T2 means what? 2000x. T2 means 2000x. So this T will point to 2000x memory location. Okay, now this T will point to 2000x memory location. Okay. So you have successfully created all the four objects. You have successfully created all the four objects. Great. What you will do, you will write just here T4 is equal to 4000x. Okay, great. Okay, now simple, you have created four objects. Simply you have created what? Four objects. Great. Excellent. Everyone understanding? I can see your chat. Everyone understanding. Great, great. Now look. Now here we have a small thing. Look. That's all. This is the small thing. Let me copy and let me paste it here. Then I will delete. Just concentrate, all of you. So first line is what? First line. Look, all of you concentrate. First line you are saying this line. T2 dot T is equal to T3. T2 dot T is equal to T3. Concentrate here. It's very, very important. T2 dot T is equal to T3. Then tell me, what is the value of T3? T3 value is 3000x. This T3 value is 3000x. T1 value 1000, T2 value 2000, T3 value 3000, T4 value 4000. T3 value is 3000x. This 3000x you want to assign on what? You want to assign on T2 dot T. This 3000x you want to assign on T2 dot T. So what will happen? Think. What will happen? What will happen? What will happen? Think. So 3000x, look, this 3000x, you want to assign on T2 dot T. T2 means what? T2 means 2000x. What is the value of T? T value is 1000x. This is very, very tricky. Please try to concentrate. I am taking little bit time. I'm taking little bit time. Look, just concentrate on this line. Everyone concentrate on this line. What you are saying T3, I need to assign on T2.t. T3, I need to assign on T2.t. So T3, where is T3? T3 is what? 3000x. 3000x, where is 3000x? Here is 3000x. Look, this 3000x value, because T3, you want to assign on T2.t. Okay, now wait. Just hold on. I think by mistake, I have pressed Control Z. So let me delete this and let me paste it here. Copy and paste. Then T2.t is equal to T3. Okay, now this line. So T3 value is 3000. 3000 you want to assign on T2.t. 3000 you want to assign on T2.t. 3000 you want to assign on T2.t. T2 means what? 2000x. What is the value of T? Look, T2 means what? 2000x. T2 means what? 2000x. What is the value of T? The T value is 1000x. So this 1000x will modify, this 1000 will x will modify to what? 3000x. This 1000x will modify 3000x. Okay. Now next you are saying T4. T4 means what? 4000x. Okay. 4000x, where you want to assign? You want to assign T3.t. You want to assign T3.t. T3.t. So whenever you are saying T3.t, look, T3 means what? T3 means what? 3000x. What is the value of T? T value is 1000x. So this 1000x will change to 4000x. This is pure object-oriented programming. Try to learn and enjoy. So you will get any complex to complex program output. 4000x. Okay, great. Great, great, great. Now you are saying T2.t. Look at the third line. T2.t. Here, T2.t. T2.t means what? Look, T2, T2, T2.t. T2.t, relax. T2.t. T2.t means what? 3000x. T2.t means what? 3000x. So this 3000x, you want to assign on T1.t. T1.t. T1.t means what? Null. So this null will change to 3000x. 3000x. Okay. Then you are saying T4.t. T4.t. T4 means 4000x and T means what? 2000x. Here 2000x. 2000x you want to assign on T2.t. 2000x you want to assign on T2.t. So T2.t means what? T2 means what? 2000x. T value means what? 3000. So what will happen? This 3 will change to, this 3000x will change to 2000x. This 3000x will change to 2000x. That's all. Now tell me, everyone understood? All of you understood, everyone? Can I give you the answer now? Come on, come on, come on. Yes. So let's say the first answer is what? The first answer is what? What is the first answer? First answer is what? Here, T1.t.val. T1.t.val. Look, T1. T1 means 1000x. 1000x. 1000x T. 1000x T means what? 3000x. And 3000x val value, 300. Understood? Everyone understood? Please look what I'm saying. I'm saying T1.t.val. T1.t.val. So T1.t.val, how you will find out? How you will find out? You will go here T1. You will go here T1. Look T1. T1 means 1000x. T means what? 3000x. And 3000x value is 300. So my first output is 300. T2.T.val. T2.T.val. Look, T2.T.val. First you go to T2. T2 means 2000x. 2000x T means again 2000x. And its value is 200. Please don't confuse. T2.T.val. T2.T.val means what? T2 is going what? T2 is going to what? 2000x. 2000x T. 2000 T is what? Again 2000x. So 2000x value. What is the value? 200 only. Okay. In the same way, you guys tell me, what is the T3.T.val? T3.T.val. What is the value? 2%. Yes. 3%. 4%. Yes. Yes. Very good. Very good. Very good. Very good. Excellent. Shankar, it's not 100. Please look at very carefully. Shankar, it's not 100. Please look at very carefully. T3.T.val. Look, I am explaining. T3.T.val. T3.T.val. So what you will do? T3. T3 means what? 3000x. Go to 3000x. 3000x T. 4000x. Go to 4000x. And what is the value? The value is what? 400. Value is 400. You got it, Shankar? What is the value? The value is what? 400. Okay. T4.T.val. T4.T.val. T4 means 4000x. T means 2000x. And 2000x, what is the value? The value is 200. So if I compile and run this program, I should get 300, 200, 400, 200. 3242. Look, 3242. Save, compile, run. 3242. Are you getting 3242? 300, 200, 400, 200. 3242. 3242. This is the power of heap and stack diagram. This is the power of heap and stack diagram. You understood or not? Tell me. Everyone understood? Super, super. Thank you, Lokesh. Everyone understood? Yes. So I'm giving you what? The confidence inside you that if you do this practice, then you can solve any complex to complex program. I'm asking one question to you guys. Without heap and stack diagram, can you solve this type of question? Please write. Think first. Without heap and stack diagram proper knowledge, can you solve this type of complex program? No, sir, you can't solve. So please try to practice. Then you will get a confidence. What confidence, sir? Any type of complex program, I can say the output, sir. So whenever in the interview room you are saying, sir, I can say the output. You give me any complex to complex program, then the person will understand you have learned Java from depth. You know the internal of Java. You know everything how it is working. And after this topic, the copy constructor topic will become fun for you. After this topic, your copy constructor topic will become what? Fun for you. It is just like nursery KG standard will become. Okay. Let me copy this program. Otherwise, I will forget. So I have copied this program. Okay. You know the output. Now, one last program of heap and stack diagram. But that last program is very, 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 very interesting. Why? Because in the last program, I have given you the concept of a static field as well as array. In the last program of heap and stack diagram, I will give you the concept of a static field, how static fields are working as well as array. You guys are ready to learn? Sairam, actually, they will give you the time. And the second thing is what? When I will do in the copy and pen, it will hardly take 1 to 2 minutes. Sairam, I hope you are understanding what I'm trying to say. You guys are excited? Should I write one program or should I show one program on array? How array is working and static field is working? You guys are ready? Come on, write in the chat window. Yes, excellent, excellent. Wow, wow. Great, 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 great. The way you guys are responding, amazing. Okay, let's see. Let's see one last program of heap and stack diagram, which is containing two concepts. One is array concept. Another one is what? Static field concept. Extraordinary concept it is. Extraordinary it is. You will get some idea of static field as well as array. Sir, what is the overview of this program? Look, so you have a class alpha, and then you have a non-static field val. You have a non-static field val, and then you have a static field here. Static int as well is equal to 200. That means you have two mixture. One is your what? One is your non-static field. Another one is your static field. Great. And you can see you have one more static field. You have one more static field. It is what? It is your non-static field. Non-static field. What it is? It is your static field. And this is also static field. Great. So two static field and one non-static field. And then to initialize this non-static field, we have a constructor. By using constructor, we are initializing this non-static field. You know, constructors are mainly used to initialize the non-static field. That means your object data. Object data means what data? Non-static fields. Because static fields are not the part of the object. Static fields are the part of the method area and it is common for all the objects. Beautiful. Okay. Sir, let's proceed. So I have one non-static field and I have two non-static fields. And this non-static field I am initializing through constructor. Great. Then move. Public class beta. Public class beta. Public static void main string of args. Alpha am1 is equal to new alpha. Alpha a1 is equal to new alpha. Okay, na? Alpha am1 is equal to new alpha. Alpha am2 is equal to new alpha. Okay, na? Alpha a1 is equal to new alpha. Alpha am2 is equal to new alpha. So you are creating two objects. You are creating two objects. And then you are calling one method field. First you say field is a static method. You are calling one method field. Field is a static method. Yes, field is a static method. Great. In this field method, what you are passing? You are passing AM1 and AM2. AM1 and AM2 you are passing. Both are alpha type. Both are reference variable of type alpha. AM1 and AM2 both are reference variable of type alpha. So you can see this field method is taking what? Two parameter variable A1 and A2 and both are alpha type. That means this AM1 value you can assign to A1 and this AM2 value you can assign to A2. Shallow copy. Shallow copy. Okay. Then this field method return type is alpha array. This method return type is array. So when you are calling this field method, then the return value you are storing in this AR. The return value you are storing in this AR, which is an array variable of type alpha, which is an AR variable of type alpha. And then AR of 0, you are writing what? AM1. That means AM1 you want to assign on AR of 0 position. We will see in heap and stack diagram. And finally, AR of 0 dot val, AR of 1 dot val. Sir, what is inside this field method? Inside this field method, return type is alpha array. So A1 dot val is equal to 15. This A1 dot val is equal to 15. And then alpha FA is equal to new alpha A2 comma A1. Alpha FA is equal to new alpha A2 comma A1 and what? Return FA. So your array concept is very, very important concept, especially when your array concept become more beautiful when you know dynamic polymorphism. When you know dynamic polymorphism, then your array concept will become more beautiful. Why? Because after knowing dynamic polymorphism, you will understand the real power of array. Why, sir? Because there is a class called object. In that object class, you can assign what? You can assign all different kinds of array. Look, it is a very, very important. So I'm coming to here to show you what that heap and stack diagram. But before that, I just want to share one small program with you. What is the power of array with a dynamic array? Where is my program? Is there any program? Uh, okay, let's say here only I'm saving one program. Look, or let's say test.java I already completed now. Here only I'm writing. Okay, na? I have this file, no worry. No. 'Worry. 'No worry. 'No. 'Worry. 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 'No. ' So when you will learn dynamic polymorphism and when you will create this type of array, look, object ARR is equal to, you can hold all heterogeneous type of values. 12, Ravi, okay, double value, okay, let's say Boolean, like this. Now, how to fetch the value? You can fetch by using system.out.println also, or you can use a for each loop. So I am using system.out.println, system.out.println. In this system.out.println, we have a class called arrays. This arrays class is available in java.util package. So java.util.arrays, and this arrays is containing one method, toString. It is a static method. In this toString, I am passing ARR. Then save, compile, run, run. Look, are you getting all the values? Then you will surprise in Java how we can hold heterogeneous type of values. How we can hold heterogeneous type of values. Okay, now even you take a class student, even you take a class student and you write here true comma new student, one object, new student, and I'm going to save it. I'm going to compile and I'm going to run. Look, I'm going to run. Then it is what? It is showing your object class toString method. So that is the real power of array. Okay, that is the real power of array. After dynamic polymorphism, you will understand that array is actually going to hold all different kinds of value. But that is not our real concept right now. Our real concept is this one. So concentrate here. Return type is alpha array, and a1 dot val is equal to 15. Here we are creating one alpha array. This is also one way to create array object in Java. Okay, where you are directly initializing the value. Alpha fa is equal to new alpha a2 comma a1 and return fa. So what is the heap and stack diagram for this program? Look, carefully listen. Very, very interesting. Code is compiling. So I'm going to write heap and stack diagram for beta.java. Heap and stack diagram for beta.java. Heap and stack diagram for beta.java. Okay. So here we have heap memory as usual, heap area, and here we have stack area. Okay, na? Heap area, stack area. Heap area, stack area. Okay. Right. You guys got the time to learn something about metaspace? Have you learned something about metaspace? Whenever you have a free time, na, please learn metaspace and permgen. Then you will get clarity. Okay, na? Then you will get a clarity. Okay. Then you will get a clarity. Okay, na? Chandra, sir, static fields are stored in a static area. But what if we put a static for object? Now object is stored in heap or static. Wait, sir, I'm explaining now. Why you are hurry? Don't be hurry. Look, everything you will get clarity. Just you watch. Metaspace and permgen, Trilochan. Whenever you have a free time, na, try to learn metaspace and permgen. Look, this program will give you the total idea, Chandra, Manikanta. Okay, sir, let's start. So first, as usual, look, it is a very confusing program. If you have a idea of method area, then you will get the complete clarity how it is working and what is the output of this program. Very, very important program. After this program, total static, non-static flow, you will understand. Okay, now total. So main underscore stack, main underscore stack. Look, okay. Then in the main underscore stack, what you are doing? Learn. It is very confusing program, guys. I am telling you again and again. In this main underscore stack, you are creating the object for alpha. Look here. Line number 18, we are right now. Right now, we are in line number 18. We are creating the object for alpha. Sir, what will happen first? Learn the universal line I am giving you. You are creating the object for alpha. I am creating the object for alpha. I am creating the object for alpha. Object for alpha. Object for alpha. First of all, what will happen? First of all, your alpha class will be loaded into JVM memory. Please learn. Now from here, we will shift to JVM memory after learning copy constructor. So I am creating the object for alpha. First object will be created? No. First class will be loaded. First object will be created? No. First class will be loaded. First class. Actually, it is a two-step process. Here, two-step process. First class will be loaded into JVM memory by using class loader, and then only object will be created for alpha class. So look, line number 18. So what will happen? What will happen? Now from your meta space, if you go learn please meta space, little bit about meta space, then you will find that now inside method area only, there is a call, something called class underscore data section. It is inside method heap area only. Class underscore data section. Class underscore data section. That means it is holding class data. It is holding class data. Sir, where it is available? It is available in the heap memory only. It is available in the heap memory only. Sir, what will happen in this class data section? Actually, your class will be loaded here. You can also say method area, no problem about this. You can also say specifically I'm talking about class underscore data. Specifically I'm talking about class underscore data. You can also say method area, no problem at all. Even your string constant pool also from 1.7 version, it is a part of the heap area. From 1.7 version, your string constant pool is also the part of the heap area. Search in the Google or ChatGPT. Now, sir, what will happen here? Look, alpha am1 is equal to new alpha. So first of all, your alpha class will be loaded. Now look how. After this, you have a total idea of static and non-static flow. So alpha class will be loaded at 100x. I am taking 100x. 1000x I am taking for object, 100x I am taking for class loading. You know, class loading first, object creating next. So alpha dot class file will be loaded. Alpha dot class file will be loaded. Look carefully. Alpha dot class file will be loaded. Okay, alpha dot class file will be loaded. All of you, please concentrate. It is very confusing topic. When alpha class will be loaded, then what will happen? When alpha class will be loaded, then inside the alpha class, whatever the static fields are there, those static fields will be initialized with the default value in the prepare phase of class loading. In the prepare phase of class loading. So how many static field? We have two static field. One is SVAL, another one is B. One is SVAL, another one is B. Okay, now two static fields are there. What about non-static field? You can't think about this non-static field right now. Why? It is a class loading phase. When this non-static field will come into the picture, when object will be created in the second layer. So in the first layer, only class loading. So only these static fields are entertained. SVAL and B, right? SVAL and B. So you have SVAL and then you have B. Okay, great. It is class loading phase, don't forget. Then sir, SVAL is a primitive variable. SVAL is a primitive variable. It is holding the value 200. So directly here you can write what? 200. Okay, great. Okay, great. So as well, directly you are writing what? 200 because it is a primitive. What about B? Sir, B is not primitive, sir. It is a reference. B is not primitive. It is a reference. So it is a reference variable of type static, which is a reference variable of type static. It will hold the address object of beta. So look here. What will happen? This B will point to 1000x memory location. This B will point to 1000x memory location. And in 1000x memory location, your beta object will be created. At 1000x memory location, your beta object will be created. Objects are always created in the heap memory. Beta object will be created. Whenever beta object will be created, all the non-static fields are going to initialize. Let me check, is there any non-static field in the beta class? So you can see beta class, there is no non-static field. We have a main method, which is a static method, and we have another method, a field, which is also static method. What is the confusion here for student? The confusion is the confusion when you will confuse when you will watch this video. So you will confuse. Sir is creating alpha class object. Sir is creating alpha class object. So at 1000x alpha object should be created. Na? No, no, no. Actually, you are creating alpha object. But first of all, alpha class will be loaded because class loading is first. When alpha class will be loaded, then all the static fields are getting the memory. All the static fields are getting the memory. So as well is a primitive, it will directly hold 200. But B is not primitive. B is reference. Once it is a reference, it is holding the address. So 1000 address, what object is created? Beta object is created. First, you tell me everyone clear with this point, then only I can proceed. Everyone clear with this point, then only I can proceed. Right now, you are in the class loading phase. Don't forget that. Okay, sir. Sir, my class is loaded, sir, successfully. My class is loaded successfully, sir. Both the static field initialized, sir. Both the static field initialized. Then it will check is there any static block is there and all those things. But I will talk in JVM architecture. Now what will happen? Now your alpha object will be created. So once your alpha object will be created, you have AM1 variable. So here you have AM1 variable. Look, AM1. This AM1 will point to 2000x, not 1000x. This AM1 will point to 2000x. And in 2000x, what object will be created? Alpha object will be created. So create alpha object here. 2000x alpha object will be created. 2000x alpha object will be created. When alpha object will be created, it will check what are the non-static fields are present in alpha class. What are the non-static fields are present in alpha class? So which non-static field is present in alpha class? Val non-static field is present in alpha class. How you are initializing this val? With the help of constructor. What value you are passing in the constructor? 9, 9, 9, 9, 9. Okay. So this val will initialize with value 9. Okay, great. Great, sir. Then after that, this is okay. After that, this line is completed. Line number 18 is completed. Move to line number 19. Sir, 19, you are creating alpha AM2 is equal to new alpha. What will happen? Again, class will be loaded? No. Again, class will be loaded? No. Again, class will be loaded? No. Why? Class is loaded only once. Class is loaded. Your dot class file is loaded only once into JVM memory. Okay. So here what will happen? Directly AM2. So here you will write AM2, AM2. Then it will point to 3000x. At 3000x, you have again alpha object will be created. At 3000x, again alpha object will be created. Then whenever alpha object will be created, val value will initialize through constructor. What is the val value? Val value is 2. Val value is 2, which is initializing through constructor. So this val value will become what? 2. Okay, great. Great. Okay, now what will happen? Look, what will happen? Now these two objects are created. Then you are calling one method field. You are calling one method field. Whenever you are calling one method field, what will happen? One stack frame will be created for this field method. So let's create one stack frame. So here I'm going to create one stack frame. Field underscore stack. Okay. Now in this stack frame, look, you have two parameter variable A1 and A2. You have two parameter variable A1 and A2. Relax. So what you will do, you will write two parameter variables A1 and A2 here. A1, A1 and A2. Okay. Then what you are passing A1, A2, look, go to the program, what you are passing. Actually, you are passing what? You are passing AM1 and AM2. So AM1 value will initialize to A1 and AM2 value will initialize to A2. Sir, AM1 and AM2, both are alpha type. Both are alpha type. A1 is alpha type, A2 is also alpha type. Shallow copy, deep copy. Shallow copy, deep copy. Shallow. Very good. Shallow copy. So go AM1 value will assign to A1. AM1. AM1 is 2000x. That means A1 will point to 2000x. AM2 is 3000x. That means A2 will point to 3000x. Cello copy. Cello copy. Okay, sir. Understood. Now, sir, after that you are saying, hello. After that you are saying A1 dot val is equal to 15. A1 dot val is equal to 15. A1 dot val. A1 is pointing to 2000x. Right now you are in field method. Right now you are in field method. So A1 is pointing to 2000x. This 2000x. So this 2000x value 9, this 2000x value 9 will modify to 15. This 2000x value 9 will modify to 15. If 2000x value 9 will modify to 15. Okay. Then you are creating one array object. Look at the beauty. You are creating one array object. You are creating one array object. What is the array object name? Array object name is what? FA. FA is your reference variable. Array is object in Java. It is a reference data type. Array is a reference data type. It is an object in Java. And just like any normal object, array objects are also created in the heap memory. Just like any normal object, array objects are also created in the heap memory. So FA is your reference variable. So here FA is your reference variable. FA is your reference variable. It will point to 4000x because array objects are also created in the heap memory only. Array objects are also created in the heap memory only. And in the 4000x, what object will be created? Array object will be created. Now look here. It's very, very important how array objects are created. So at 4000x, what array object will be created? What array object will be created? Alpha array object will be created. Line number 32. Alpha array object will be created. Alpha array object will be created. Alpha array object will be created. Sir, in normal object and array object, what is the difference, sir? Sir, in normal object and array object, what is the difference? Not much more difference. Only one thing. Only one thing. What? Only one thing, sir. What, sir? Sir, array objects are created by using placeholders. This is called placeholders. Array objects are created by using placeholders because array objects are going to hold multiple values. That's why they are created by using placeholder. Okay, sir. In this placeholder, you are passing A2, A1. You have two data, A2, A1. So here what will happen? Here, look, here A2, A1. Sir, A2, A1, A2 address is what? 3000x. You are in field underscore stack method, don't forget. So A2 address is 3000x. That means it is referring to 3000x memory location. Java is beautiful. And then A1 is 2000x. That means it is referring to 2000x. Okay. This is your array object. This is your array object. Okay, now this is your array object. Okay. So array object is created by using placeholders. And in the first, you are passing what? In the first member, you are passing A2 and second member, you are passing what? A1. So in the placeholder, what will happen? A2 value is 3000x and A1 value is 2000x. Great. Then what? Then you are saying return FA. Return FA, and that FA is going to store in this AR variable in the main method. Return FA, and that FA you are going to store in this what? Main method AR variable. So what will happen in the main method? In the main method here, you have one variable AR. That AR variable will also point to 4000x. Why? Because FA value you are returning to AR. FA value you are returning to AR. Everyone, please try to understand. FA value, this FA value you are returning to what? AR. Okay, sir. Now This method is over. This field underscore stack method is over. This field underscore stack method is over. Once it is over, it will be deleted from the stack frame. Okay, now? Once it will be over, it will be deleted from the stack frame. Now you are in the main method. You are in the main method. Then in the main method, you are saying AR of 0 equal to AM1. AM1 value you assign to AR of 0. AM1 value you assign to AR of 0. What is AM1 value? AM1 value is 2000x. AM1 value is 2000x. This 2000x value, this 2000x value, you are saying, this 2000x value you are saying assigned to AR of 0. Sir, AR is pointing to what? 4000x. 4000x you see here. So let me change the color. So what is the position? What is the position of this 3000x in array? This position is 0. What is the position of this 2000x? This position is what? 1. Then what you are saying? What you are saying? You are saying, learn carefully. What you are saying? Once again, you look at here. You are saying AM1 value you assign to AR of 0. AM1 value you assign to AR of 0. Okay, now let me copy these 3 lines. Okay, let me paste here. So AR of 0, AM1 you are assigning to AR of 0. AM1 means 2000x. AR of 0 means what? 3000x will change to 2000x. This 3000x will modify to 2000x. That means in the array of 0, now you have 2000x. Okay, then you are saying AR of 0 dot val, AR of 1 dot val, AR of 0 dot val, AR of 1 dot val, AR of 0 dot val, AR of 1 dot val. AR is pointing to 4000x. AR is pointing to 4000x. Then 4000x means 2000x. 2000x, what is the val value? Come on, tell me what is the output? Both are 1515 because both are pointing to 2000x memory location. Will you get 1515? Come on, come on, come on. Will you get 1515? Here we have 15. AR of 1 is also pointing to 2000x. Here also we have 15. Okay. Compile this program. Save. Compile. Run. Look, I'm executing. What is the output? 1515. Guys, you understood that how class is loaded. Even if you have any doubt in the JVM architecture, I will explain. So generally my class problem is what? Only one problem, little bit more time. So I'm thinking I will complete in 3 days, but it is taking more time. This is the program. Okay. So here you have completed your heap and stack diagram. Now you go to copy constructor topic. Look. Now I will go to copy constructor topic. So guys, officially there is nothing called copy constructor in Java. Officially there is nothing called copy constructor in Java. In Java, officially there is nothing called copy constructor. Of course, it is very, very important, but officially there is nothing called copy constructor. In Java, we have total 3 types of constructor. 3 types of constructor. 3 types of constructor. What are those? In Java, we have total 3 types of constructor, guys. Okay, now what are those? The first one is default no argument constructor. Default no argument constructor added by Java compiler. Added by Java compiler. Okay. Second one is what? Second one is no argument or non-parameterized constructor. Non-parameterized constructor. So written by user without any parameter. Written by user without any parameter. Okay. Now few students, few guys are saying what? Both are same only. Few guys are what? It is a controversy issue. Okay. Both are saying what? Both are saying same only. Okay. Both are same only. You will find that few of your friends will say that both are same default and no argument constructor both are same only. Both are same only. First you answer one question. First you answer one. I'm giving you the practical proof. First you answer one question. When compiler will add constructor to your class when you have not written any constructor, true or false? When compiler will add constructor to your class when you have not written any constructor, true or false? True or false? Yes or no? True. Then look here. I'm giving you the practical proof. If anyone is what giving you the contradictory, no problem. I'm giving you the practical proof. Java P, java.lang.arithmetic exception class. It is a predefined class of Java. We are using this class in what exception handling. You can see here public class java.lang.arithmetic exception extends from java.lang.runtime exception. Sir, you can see here we have two constructors are there. One constructor is taking string as a parameter, another constructor is not taking any parameter. Can you say it is a default constructor? Impossible. Can you say it is a default constructor? Impossible. Why? Because whenever you are writing a constructor, whenever a developer is writing a constructor, compiler will not add any constructor. Compiler will not add any constructor. So is it a default constructor? No. It is user written constructor. User has written this constructor without any parameter. User has written this constructor without any parameter. So this is the best proof. What? The default and no argument constructor both are not same. Both are different. And the third one is parameterized constructor. Third one is parameterized constructor. The copy constructor comes under this category only. Because in copy constructor, you are passing what? You are passing the parameter only. Okay. Sir, what is copy constructor? So as I told you, copy constructor, there is no term. So here I am trying to write, look, passing an object reference to the constructor. Passing an object reference to the constructor. Passing an object reference to the constructor. Sir, what is the meaning? Look, we can pass an object reference to the constructor. We can pass an object reference to the constructor. So we can copy the content of, one object to another object. That's all. Just to copy the content of one object to another object, we are using copy constructor, you can say, or we are using what? This concept. Just to copy the content of one object to another object, guys. Okay, now just to copy the content of one object to another object. Just to copy the content of one object to another object, we are using what? Copy constructor, or we can say it is called passing object reference to a constructor. Sir, can you show one program? Look, I'm trying to show one program. All of you. Very interesting program. Very important. Here I will tell you deep copy also. So what is the program? Let's say this is the workshop. Now here, let's say right click on SRC, new package com.ravi.copy constructor. You know, Ravi com.nit. Not copy constructor. Now what I'm trying to do, right click, new class. Suppose I'm taking copy constructor. Main method, click on finish. Okay. Then this is my actually ELC class, executable logic class. Here I'm taking one class, new class. Suppose employee. Very interesting program it is. Suppose employee. In this, I am taking what? int, let's say employee ID. Intensely, I have not declared private. Later, I will declare private. And string employee name. Now, how to initialize these two non-static fields? To initialize these two non-static fields, we are using constructor. So we are using constructor to initialize these two non-static fields. Great. Now, after that, here, let's say if you want, you can take a toString to print the object properties. Source generate toString. If you write this one here, what is the benefit? Or if you write this here, what is the benefit? If you write here, look, so at the time of interpreter, that means at the time of interpreting the code, your interpreter will simultaneously execute this entire line. Okay, now, but if you write this here, then interpreter has to execute this line independently. So that's why this is most preferable. But, but for indentation problem is what? To understand the program in a better way, we are using this way. But you can use anyway, your choice. So employee, and then let's say here, right click, new class manager. So total three classes are there. One is employee class, employee ID, employee name, and one is manager class. In this manager class, what I'm trying to do, private int manager ID, private string manager name. Here I'm taking one constructor. Look at these variables or these fields I have declared with private. These fields I have declared with private. Here I'm taking a constructor. In this, I'm passing employee EMP. Employee EMP. What is the use of any constructor? So any constructor is used to initialize its non-static field. So that means here what I can write? I can write this dot manager ID is equal to, and I can write this dot manager name is equal to. What is the use of any constructor? What is the use of any constructor? To initialize the non-static field of the class. So I have written this dot manager ID, this dot manager name. Even if you want, I can initialize like 101, and I can initialize what? A Scott. Like that. No problem. Okay, we can do like this. But what is copy constructor? We can do like this. What is copy constructor? Look, what is copy constructor? I am going to main class, that is my ELC class, executable logic class. Here, I'm going to create the object. You think you have two classes. One is employee class. An employee class constructor is taking employee ID and employee name. And one is manager class, which is taking what? Employee object as a parameter, employee reference variable as a parameter. That means we can't create an object for manager without employee object. Think logically. If I want to create manager class object, what is required? Employee object is required. I cannot directly create the manager object without employee object. So you can say manager object is depending upon employee object. So first I need to create employee object. And if you think logically also, actually employee and manager, the same employee becomes manager after 2 years. After getting promotion, that means employee has joined the IT company, and after doing hard work in 2 years, the same employee becomes manager. So first manager came or first employee came? Come on, write in the chat window. First employee came and manager came, employee came. So first you need to create the object for employee. Look, employee E1 is equal to new employee. Then here ID I am passing 101 and name, suppose I am passing Mr. Scott. Okay. Now my employee object is ready. I am creating manager object. Manager, let's say M1 is equal to new manager. Manager is taking what? Manager is taking employee as a parameter. Manager is taking employee as a parameter. So this even I am passing to here. Look, even is a reference variable which is referring to 1000x memory location. Even is a reference variable which is referring to 1000x memory location. The same even you are passing. The same even you are passing. So that even will assign to what? That even will assign to this EMP. EMP is equal to even. Then tell me, even and EMP both are pointing to same object. Right in the chat window. Even and EMP both are pointing to same object. So it is a shallow copy. Is it a shallow copy? Yes, 1000x. Absolutely correct. Is it a shallow copy? Yes. So now think this EMP and even both are pointing to same object. So what I can do from this EMP, which is pointing to employee object, which is pointing to employee object. Why? Because even you have assigned to EMP. Even you have assigned to EMP. So EMP, which is pointing to employee object, from this EMP, can I fetch employee ID? Yes. That means from this employee object, I am taking employee ID, and that employee ID I am assigning to manager ID. Because the same employee becomes manager after 2 years. Same employee becomes manager after 2 years. So that employee ID I am assigning to manager ID. And here also EMP dot employee name. Great. This is called copy constructor. Copying the content of one object to another object. Copying the content of one object to another object. And now you print here. Source generate to string. Good. Then you just go and you write sys out M1. Run this program. Look, manager ID is 101. Manager name is Mr. Scott. Actually, this guy is our employee, but promoted to what? Manager. It is copy constructor. You understood? You understood? Yes, Srikant, you can use super off, but that is purpose is what? To call the super class constructor. It is not an inheritance program, so that's why I'm not discussing. Okay, now it is not an inheritance program. That's why I'm not discussing. You know, it is not an inheritance program. Okay, then what you learn from this program? You tell me. Can I copy the content of one object to another object? Can I copy the content of one object to another object? Yes. That is copy constructor. The main purpose of copy constructor to copy the content of one object to another object. Very good. Excellent. Very good. Excellent. Yes, Srikanth, actually what happens now, look, actually what happens now, what, let's say, think what I'm trying to say, here two separate objects are created. Here two separate objects are created. So now, of course, manager has called, look, first let me complete, then I'm talking about that. First, let me complete, then I'm talking about that. Let's say, first, what is the another thing? Have you noticed one thing, all of you? Let me complete, then I will talk about that. So first thing you look at here, in the employee class, you have not declared your fields as a private. That means you are not achieving data hiding concept. If you don't declare your fields as a private, non-static fields as a private, so it is your data can be accessible by anywhere, everywhere, from anyone, everywhere. So to protect my data from unauthorized access, I can declare private. It is not encapsulation. Declaring your data is not encapsulation. It is what? It is data hiding. What is encapsulation? Writing setter and getter for this private method is called encapsulation. Writing public methods for your private data, writing public methods for your private data like setter and getter is called encapsulation. Only if you declare private, only if you declare private, it is not encapsulation. It is data hiding. It is data hiding. What is encapsulation? Encapsulation means writing public methods like setter and getter to give you the permission to access your data via methods. So by using setter, you are giving the permission. Okay, you can modify my employee ID, but with my data validation. Let's say if I write here setter, then what I can write by using setter, I can get the employee data from outer world. If someone is passing -9, then inside the setter, I will write the validation. What validation? If the outer world data is less than equal to 0, don't initialize. Don't initialize. That is the power of encapsulation. So sometimes students are saying this is encapsulation. This is not encapsulation. This is data hiding. Writing public methods for this private data is encapsulation. But look at the moment I have written here private, the moment here written here private, I am started getting what compilation error. Why? Because now these are the private fields. Private fields I cannot access. Private field I cannot access. Then what is required? Encapsulation is required. So what I will do, I will write getter. Right now getter is required. I will write getter, source, generate getter. I will write getters for these two non-static fields. And instead of directly accessing the data, what I will use emp.get employee ID and emp.get employee name. Understood? Understood, everyone? Yeah. And let's say here also I'm taking setter and getter. Source, generate setter and getter. Okay. Or look, you can also do another thing. Okay, I have created one program here, copy constructor. Now quickly look at if I create this program is running, no problem. Now quickly I am creating what? One more program. Look, suppose here only I am creating one more program. Class. Okay, you want this program now. Okay, wait, you want this program. So let's say another copy constructor program I'm telling you. Quickly, it will take hardly 1 or 2 minutes. New class, copy constructor. And let's say here I'm giving you the complete idea of deep copy. Main method, click on finish. So deep copy means what? Look, I'm creating one class, let's say player. Okay, then let's say product, class product. Here, let's say private int ID, private string name. Then I have taken one constructor, parameterized constructor to initialize my non-static field. And here I have taken one more constructor, public product. Both are parameterized constructor, but constructor overloading. Product P1. Then what I have done here I have done what this dot ID is equal to P1 dot ID. Now ID is available in the same class, so you can directly write. There is no getter required. This dot name is equal to P1 dot name. Okay now? And now here I'm taking setter and getter and two string. Source generate setter and getter. Here I'm taking two string. Source generate two string. Great. Then I'm going to create the product object. I'm going to create the product object. Product P1 is equal to new product. One product object is created. Let's say I'm passing 101 and let's say mobile phone. Oh. And then sys out P1. Run this program. You are getting 101 and mobile. Then you are creating what? Another object. product P2 is equal to new product. Now here what are you doing? You are writing P1 only. That means you want to copy the P1 data to P2. Sys out P2. Here also because you have copied the data, so everything is same. Then you are saying what? After change, modification. What modification? Look, you are saying P2 dot set ID, you modified to 999, and let's say P2 dot set name, you modified to what? Let's say iPhone. Now after modification, hello, after modification, you are trying to print P1 and P2 both. P1 and P2 both you are trying to print. Look, last two outputs you visit. So last two output, both are same output or different output? Last two output, both are same or different? Different. This is called deep copy. This is called deep copy. So in deep copy, what will happen? You create two different objects. If you modify the content of one object, if you modify the content of, like you are modifying the content of P2, you are modifying the content of P2, then what will happen? P1 will modify, P1 will remain same, P1 will remain same. Suppose you are modifying the content of P1. Okay, now P1 you modified. Actually, P2 has copied the data from P1 and now you are modifying the content of P1. Look, then here ID 999 iPhone, but this is same. Even he had copied the data, but it is same. This is called deep copy. Understood deep copy, all of you? This is called deep copy. So now we have learned what shallow copy, deep copy both. Now I am going to show you a little bit idea of JVM architecture. Look, JVM architecture, I'm giving you the idea. Keep concentration, all of you. So time is short. Okay, I will copy this program and I will share to the notes. Don't worry. Time is short. So what I am trying to do in the webinar, I have already this look JVM architecture. Just I want to show. Carefully listen. Uh, Notes I will share you after this class. I will share you the WhatsApp group link. You join the WhatsApp group link. Today I will again share all the notes. Even I will share the link also. This video link. It is a YouTube live video, so it is available in YouTube. You can watch for your reference later. Okay, just let me complete this. Then I will share. Yeah, yeah. Please, I will share the notes. So let's see what I am trying to show you here. All of you, concentrate. Look, in order to execute a successful Java program, we need three parties. Number one, user. User means person who writes Java program. Person who writes Java program. Number two, Java compiler. Number three, JVM. Now, what is the life cycle of Java program? So first we are writing test.java, Java source file. Second, we are writing Java compiler. Second, we are giving the source code to Java compiler. Now, what Java compiler will do? Don't say ever Java compiler is going to generate machine code. It is a wrong statement. Java compiler will generate bytecode, not machine code. Bytecode we submit to JVM and JVM will generate the output of the Java program. Okay. Sir, the entire JVM architecture is divided into three parts. The total JVM architecture is divided into three parts. Number one, class loader subsystem. Number two, runtime data areas. Number three, execution engine. Please look, class loader subsystem, runtime data areas, and then execution engine. Total three parts. In the entire JVM architecture, you have three parts. Now, if you go components in JVM architecture, the total JVM architecture diagram, this is the total JVM architecture diagram. So you can see here, first part is what? Class loader subsystem. It is very, very important because at the time of loading your .class file, all your static data members are executed. How many static members we have? Total 4 members. A static field, static block, a static method, and a static nested class. I repeat, a static field, a static block, a static method, and a static nested class. So all these four members are loaded and executed at a time of class loading. Now you can see runtime data areas. In this runtime data areas, which is also known as memory areas, we have method area. In this method area, your all the static fields and all the class informations are available. You have a heap area. All your objects are stored in this heap area. You have a Java stack. All your methods are executed in this stack memory. PC register. Sir, in Java, we have a multi-threading concept. Multi-threading means what? We can create multiple threads. So each thread is having their own instruction. Let's say one thread is doing something, another thread is doing something, another thread is doing something. So how we are going to hold the executed instruction of the thread? So we are going to hold by using PC register. Every thread is having its own program counter register to hold the currently executing instruction of the thread. Now, what about native method? To hold native method information. Sir, what is native method, sir? Native method means the method written in native languages like C and C++. It is not written in Java language. Those are called native method. Now, to work with native method, you need native method library. So you have a native method library, native method interface. Native method library and native method interface. Here you can see you have an interpreter and JIT compiler. Interpreter is going to execute your code line by line. Interpreter is slow in nature. Why it is slow in nature? Let's suppose in the interpreter, you make a mistake or you made a mistake at line number 9. In Java program, you made a mistake at line number 9. Then you resolve the issue. Your problem resolved. Then from where interpreter will start? Again, interpreter will start from line number 1. So interpreter is slow in nature. To boost up the execution, to increase the performance of Java program, they have given JIT compiler. Now, what JIT compiler will do? It is basically doing two things. What? It will hold all the repeated code instruction. Let's say you are calling the method multiple times or any instruction which is repeatedly available in your program, which is repeated multiple times in your Java program. Then what this JIT compiler will do? JIT compiler will hold those repeated instruction and make it directly available to JVM at the time of execution. First, it will hold those instructions. It will convert those instructions into native code and make it directly available at the time of execution. So this is how Java is becoming more fast. Java is becoming more fast. Now, among all these, look, if I go slowly, first class loader subsystem. This is your class loader subsystem. Guys, class loader subsystem. Very, very important. Sir, in this class loader subsystem, you have three phases: loading, linking, and initialization. Loading, linking, and initialization. In the loading phase, what will happen? Look, in the loading phase, what will happen? Sir, loading phase is responsible to load your .class file. Loading phase is responsible to load your .class file from different memory location. Now, in order to load your .class file from different memory location, internally it is using three class loaders. What are those? Number one, bootstrap class loader. Number two, bootstrap class loader is also known as primordial class loader. Number two, platform class loader. It is also known as extension class loader. From Java 9 version, the name is changed from extension to platform class loader. From Java 9 version, now it is platform class loader, not extension class loader. Up to 1.8, it was extension class loader. They have changed the name platform class loader because they have introduced module system. Okay, now they have introduced module system. What is module system? I'm telling you. Application class loader. Sir, what are the use of these three class loaders, sir? Sir, what these three class loaders will do? Listen carefully. What these three class loaders will do? Sir, Bootstrap class loader is responsible to load only predefined .class file. That means all your Java API files are loaded by using Bootstrap class loader. All your predefined .class file is loaded by Bootstrap class loader. Sir, Bootstrap class loader is loading the .class file from where, sir? Look. So Bootstrap class loader is loading the .class file from a jar file called jrt-fs.jar. Sir, where it is available? Go to your C drive. Okay, then go to Java. Okay, today's my system is different. So, program file. Java. Then here you go to binary, lib. And in this lib, you can see grt hyphens dot jar. Please look at this path. C program file Java JDK lib and what grt hyphen fs dot jar. Grt hyphen fs dot jar. So in this jar file, your dot class files are available. All your dot class files are available in this jar file. Java archive file. Java archive file. So what happens? Look, whenever you are installing Eclipse IDE, then let's say we are in a webinar. So you can go here. Look at it carefully, all of you. This is what your SRC source folder, and this is GRE system library. You go to GRE system library, and you go to GRE system library, and if you move it little bit this side, hmm, then you can see here. You can see here. Look, Java base. Sir, from where this Java base is coming? Now, what is Java base? Look, this Java base is containing all the packages. Java.lang package. Open this Java.lang. Look, all your Java.lang predefined classes, character class, byte class, very important in JVM architecture, class loader class. Okay, now compiler class. Okay, so many classes are there. All these classes are available in Java.lang package. Look at your integer class. Okay, now long class, math class. Okay, now negative array size exception class, no class, a def found error. So all these, even float class, look here, a float class. So all your dot class file is available here. Sir, where it is available? It is available in this java.base, java.base. Okay, and from where it is coming? C program file Java JDK lib grt hyphen fs dot jar. Sir, what is this java.base, sir? Sir, it is module system, sir. Sir, it is module system, came from Java 9 version. This is a module. This is a module. It is a very new feature. Java 9 it came, module. Java compiler, Java data transfer. Okay, think about in Java.base module. In Java.base module, so many packages are there. So many packages are there. So many packages are there. This is java.lang. But what is the important thing? Look, it is taking what? It is coming from C program file Java JDK libgrt hyphen fs.jar. So all these predefined dot class files, all these predefined dot class file, who is responsible to load? Bootstrap class loader is responsible to load. Sir, what about platform class loader? Look, what platform class loader is doing? Look at carefully, all of you. New folder, let's say webinar, or let's say web. I'm writing web. Just concentrate here. Web. Go to the file, new Java. I want to create, let's say, one file. Please concentrate, all of you, very important. Alpha class, public class alpha. I'm going to save. So I'm saving in the desktop, alpha. Sorry, desktop. What is the name? Web. In this web, alpha.java. Alpha.java. Okay. Then I'm taking another class, file, new Java. Let's say beta.java. It is beta.java. Save. So same in the desktop, desktop, web, beta.java. Sir, I have two dot class files, sir. Alpha.java and beta.java. Alpha.java and beta.java. Where it is available? It is available in the web. It is available in the web folder. Okay? It is available in the web folder. Then open it, compile, CMD. Okay, look, CMD. Hello, listen carefully, CMD. Sir, is there any command to compile all my .java file once? Yes, Java C star.java. It will compile both the Java file, alpha.java and beta.java. You will get two dot class file. Two dot class file is there. Look here, alpha.class, beta.class. Okay, sir, what? Now look, jar cf, jar cf nit.jar and a star dot class, a star dot class. Sir, here one jar file is created, sir. Sir, here one jar file is created. Look, NIT jar file. This is the command to create a jar file. And why I have written star dot class? A star dot class means in this NIT.jar, I want alpha dot class and beta dot class. In this NIT.jar file, I want alpha dot class, beta dot class. Okay, then you go to your Eclipse ID. You go to your Eclipse ID and you can see here, if you go back, you can go to any project. You go any project. You go to Enum project, GRE and SRC. Concentrate. You go to exception, GRE and SRC. You go to functional interface, GRE and SRC. You go to hazard relation, GRE and SRC. Now let's say in this hazard relation, I want to use this alpha and beta class. How to use? How to use this alpha and beta class? Learn carefully. Create file. Create file, CF means. Then here what I'm doing, right click, build path, configure build path. Look, then add external jar. Go to desktop, then web, open this web. Look, nit.jar. I have added this jar file. The guys who learn advanced Java or who have completed advanced Java can understand easily. Jar file I have added. Apply, apply and close. Look, now here one reference library came. Now here one reference library came, new reference library. Earlier only SRC and GRE system library was there. Now you have a reference library. Open this reference library, nit.jar. Open this jar, default package. Open this package, alpha and beta. Both classes are available. Think about this. Think about this. Understood all of you? How to create jar file, how to import your jar file in your Eclipse ID. Beautiful it is. So guys, look, what I am trying to say, if any third party jar file is there, like I have created one nit.jar, I have created one nit.jar. So that nit.jar is containing alpha.class and beta.class. So which class loader is responsible to load that alpha.class and beta.class from third party jar file? So your platform class loader is responsible. Your platform class loader is responsible to load the .class file from the third party jar file. So Bootstrap is responsible for predefined .class file. Platform class loader is responsible to load all the .class file which are given by third party jar file. So if you learn JDBC, then in the JDBC you will learn OJDBC 11.jar or OJDBC 14.jar. So in this OJDBC 11.jar or OJDBC 14.jar, Oracle has given some class. Oracle.jdbc.driver.oracle driver. So that is loaded by platform class loader. Now, what about application class loader? Your user defined class, test.class, student.class, demo.class, it is loaded by application class loader. So this is what your loading phase. This is your loading phase. Two more points. Sir, if all the class loaders are unable to load the .class file, then you will get a runtime exception, java.lang.class not found exception. If all the class loaders are unable to load the required .class file into JVM memory, you will get an exception, java.lang.runtime exception, java.lang.class not found exception. Okay. Second point, sir, in order to load these classes, internally JVM is using one algorithm. What is that algorithm? Delegation hierarchy algorithm. Delegation hierarchy algorithm. What is that delegation hierarchy algorithm? I am explaining. Wait. I'm explaining. Wait. Number two, you have a linking phase. In the linking phase, what will happen? In this linking phase, first phase is verify. What this verify phase will do? It will verify your loaded .class file. All your .class file loaded from different memory location. Who is going to verify? This verify module is going to verify. Sir, internally, this verify module is containing one component. What is that? Bytecode verifier. What this bytecode verifier will do? It will verify your loaded .class file. It will verify your loaded .class file. And if any suspicious activity is there, Any small, let's say your dot class file is modified by someone else, your dot class file is generated by dummy Java compiler, then immediately it will execute the program execution by throwing a runtime error, java.lang.verify error. That is the reason Java is the most secure language of this world. Why Java is the first choice for all the banking application, finance application, all types, security types of project, all security projects, first choice is Java. Why? Because because Java is having this verify module, bytecode verifier, and Java is the most secure language. Okay, one just a small point from my side. So people are saying Python is a competitor of Java. I am saying Python is not a competitor of Java. Python is very good in one or two particular domain. Let's say data science, machine learning. Python is doing well, no doubt about that. But Java is everywhere, sir. You know, 3 billion devices are running on Java. 3 billion devices are running on Java. Just search in the Google. 3 billion devices are running on Java. Java is everywhere. And when you talk to any secure project, let's say banking project, finance project, government projects, then only one choice Java. Java is versatile. Everywhere Java is available. Python is very good, but in one or two particular domain. So Python is not the competitor of Java. Okay. Sir, what about this prepare phase? Sir, in this prepare phase, now learn. In this prepare phase, what will happen? In this prepare phase, your this prepare module will verify the class from top to bottom and it will search for your static data member. All your static data member, all your static data member will initialize with a default value and memory will be allocated. So prepare is having only two. What is that? All your static data member will get the memory and it will initialize with default value. It will initialize with default value. Suppose you have written what? A static int x is equal to 100. A static int x is equal to 100. Then in the prepare phase, what will happen? First of all, for your x variable, x static field, 4 bytes memory will be allocated because integer is taking 4 bytes of memory. And then it will initialize with default value. What is the default value? 0. So remember, you are writing static int x is equal to 100. But in the prepare phase, what is the value? 0. That is the default value. Then what this resolve phase will do? Now, Niket, this resolve is very confusing topic. What this resolve will do, sir, it will convert your symbolic references into direct references. It will convert your symbolic references into direct references. Sir, what is the meaning? Look, new class, webinar, save. So let's say here in the web, I have saved webinar.java. Okay. Then let me compile. Web. Let me compile CMD, Java C, webinar.java, Java, Java P hyphen verbose, BRBOSE. Look, this is the command to get the internal details of dot class file. If you want to get the internal details of dot class file, this is the command. What is the command? Java P hyphen verbose webinar dot class. Then here what happened? Look here, there is something called get static. Look, get static, get static. What is the symbolic reference? Hash 7. This hash 7 is the symbolic reference. Go to hash 7. Hash 7 is saying what? Hash 7 is saying it is a field and reference. Field and reference means hash 8 and hash 9. Go to hash 8. What is hash 8? Hash 8 is a class. For class information, you need to go to hash 10. Look, you are going from hash 8 to hash 8 to hash 10. You are not right now. You are not considering this hash 9. So from hash 8, you are going to hash 8. Hash 8 is representing one class. For class, you need to go hash 10. Hash 10 is UTF-8, where the class name is java.lang.system. Now you go to 9. This 9 is saying what? Go to 9. 9 is saying name and type. For this, you go to 11 and 12. 11 is what? Out. System.out. What is 12? Out is a reference variable of what type? Print string. And then what you are printing? Look, you are printing what? Hello world. So these symbolic references will be converted into direct references by using resolve phase. By using resolve phase. In this resolve phase, your symbolic references will be converted into direct references. Okay. Then, sir, in the class initialization phase, what happens? Okay, keep patience. In the class initialization phase, what happens? In the class initialization phase, a static field and static block both are having same priority. In the class initialization part, a static field and static block both are having same priority. Whosoever will come first will be executed first. A static field is coming first. A static field will be executed first. A static block is coming first. A static block will be executed first. A static field is coming first. A static field will be executed first. A static block is coming first. A static block will be executed first. And second point, all your static data member will get original value. Look, you told the static index is equal to 100. So in the prepare phase, the value was 0. But here your value will become 100. So your 100 value will become in the class initialization phase. Now I want to show you two programs. Okay. Of course, it is not possible to complete today. So many things are there. So many things are there. This diagram is there. So I just want to discuss two programs and then we will end. And in the future, again, I will take one more webinar or two or three more webinar. Then I will explain this topic. Look, so just I want to give you two programs and then you answer and then we will end this session. And definitely then we have more seminar in the future. But as per your request in the comment. Okay. So right click on SRC, new package. What is that? com.ravi.jvm architecture. JVM architecture. JVM architecture. Just two programs. Look at to give you more clarity. Here I am writing what? First program. New class, let's say JVM test 1. Here I am writing one class. Let's say class is test. Here I am writing one constructor. This is constructor. Sys out. So no argument constructor. And here I am writing one non-static block, guys. It is a non-static block. It is a non-static block. Non-static block. You know, no argument constructor and non-static block both are executed when the object is created. When object is created, then only these two blocks are executed. Here we have a static block. When static blocks executed, a static block executed at the time of class loading. A static block executed at the time of class loading. Now, constructor and non-static block both are depending upon object creation. A static block executed at the time of class loading. Here in the main method, I am going to write one line, sys out, let's say main. I have not created object. Can you tell me what is the output of this program and what is the order of the output? I have just written here main. I have just written here main. I have not created any object. Can you tell me what is the output of this program? And what will be the order? Say, most of the answer I am observing is static block and main. Static block and main. Most of the answer is a static block and main. Static block, then main. No, there, no, look, guys, no argument constructor and non-static block will not be executed. Why? Because object is not created. Use common sense. No argument constructor and non-static block will not be executed because you have not created the object. So what is the answer? Tell me. So guys, everyone is saying what? Everyone is saying what? Output is a static block and main, but you will surprise the output is only main, not a static block. The output is only main, not a static block. Look, only main, not a static block. A static block not executed. A static block not executed. Why? Because your test class is not loaded. Search in the Google how many ways we can load the dot class file into JVM memory. That is a problem. That is a problem. That is the problem, guys. Okay, now that is the problem. Your static, your class is not loaded. How your class will be loaded? If you create the object, then your class will be loaded. Look, so when class will be loaded after this line. So now after this main, you will get the output first static block, then non-static block, and then no argument constructor. But after main, a static block, non-static block, and no argument constructor. Look, first main, then you have a static block, non-static block, no argument constructor. Everyone understanding? Come on. Search in the Google or Chat GPT how many ways we can load the dot class file, you will get the answer. Okay, next. Let's say here I have written what static. Now remove this. Static test T1 is equal to new test. Last program. And then you have what? Static block here. I think this program is already there, so I can save my time. Wait. JVM architecture. Yes, this program is already there. Let's concentrate, all of you. Look here. Please look, try to concentrate. So here your class name is test. Your class name is test. Okay, this final is not required. Class name is test and public static test T1 is equal to new test. Public static test T1 is equal to new test. You have a static block, you have a non-static block, and you have a constructor. Then you know constructor super means it will go to the object class. And here I have created the object. In the main method, I have created the object. Only object is created. Now you know object is created means two process. It is a two process. Number one, class loading plus object creation. Can you tell me the output of this program? Class loading plus object creation. Last program. Can you tell me the output? Okay, related to previous example, but what is the output? What is the first output? Tell me. Just you tell me first output. What is the first output? Everyone. What is the first output? All of you, please write. What is the first output? Guys, this is also wrong. First output is not a static block. First output is not a static block. Learn. What is the first output? Learn. First output is not a static block. First output is what? Look, as I told you, these two, now don't write anything, just concentrate. These two, your static field and your static block, both are having same priority. Your static field and static block, both are having same priority. So whosoever will come first will be executed first. So first your static variable is coming. Look, in the prepare phase, this T1 will become null. In the prepare phase, what I told in JVM architecture. And now when class initialization phase will come, then it will get the original value. What is the original value? Original value, you are saying new test. When you are saying new test, then due to this new test, what will happen? This constructor will start executing first from here. From here, this constructor will start executing. Here, super keyword is there, which is added by Java compiler. It will go to the object class. And when it will come from the object class, the second line is reserved for what? Non-static block. So your first output is what? This is your first output. First output is what? Non-static block. Second output is what? No argument constructor. No argument constructor. Then after executing these two, when this object is created completely, then your control will move forward. Then your third output is a static block. static block. First of all, non-static block, no argument constructor, and then a static block. Then class loading completed. When class loading completed, here two phases there. One is class loading and another one is object creation. Class loading completed. Now object creation started. Object creation started means again it will come here. Again it will go from super keyword object class. From object class it will come back. It will print first non-static block, and then it will print no argument constructor. Look. So non-static block, no argument constructor, static block, and again non-static block, no argument constructor. Please look at the output of this program. Look, non-static block, no argument constructor, static block in the middle, and again non-static block and no argument constructor. And what is the magical thing, you know? If you write, look, what is the interesting thing? If you write this line here, let's say I'm writing at last. Now, as I told you, static block and static field both are having same priority. Whosoever will come first will be executed first. Now you can see you have a static block first. You have a static block first. So first of all, static block will be executed. Look. Now, first of all, what is executing? First of all, static block is executing. That is the practical proof that your static block and your static field both are having same priority. I hope you understood. So guys, that I have talked, today I have talked about that only. I will share the notes. I will share the notes. Meanwhile, I am sharing you what? I am sharing you what? The WhatsApp link. Please try to connect with the WhatsApp. Then I will resend all the notes once again. I am giving you the link. Please try to connect, all of you. I will share the complete notes today, once again. Look at your chat window. I am sharing. If you have already connected, ignore this. If you have newcomer, please try to connect. Please try to connect. Then I will share the complete notes. All the notes I will resend. Yes, Chandra, we are teaching as a Spring Boot microservices. We are from last 22 or 23 years, we are serving the IT industry. Not only in India, even our students are in California also. We are dealing with California students, Australia students. So everywhere. And it's very proud moment to say that you go anywhere in India, not in Hyderabad, Bangalore, Kolkata, Gurgaon, anywhere you will go in India, you will definitely find one student in your company, in your IT company, one student definitely you will find from Naresh IT. That is the brand image we have created from last 22 or 23 years. So we are really hard worker. We know student career is very, very important, and we are very happy to make the student career. That we are doing from last 22 and 23 years. Yeah, Chandra, I'm dealing with the core Java. So I'm Oracle certified faculty and I am dealing with core Java course here in Naresh IT, Hyderabad offline course. Yes, you can get complete information from our official website. Our official website is nareshit.com. You can get complete information from here. This is our official website, nareshit.com. Okay, now? And we are providing first demo classes. If you like demo classes, if you enjoy, you talk to faculty, you ask, sir, what you will teach. And based on that, we are going what? We are going to take the admission. We are not directly forcing you to take the admission. First, you attend the demo class. You contact with the faculty. What are the material faculty will deliver? And then you can what? You can go through that. But yes, of course, we are from last 22 and 23 years, we are the career maker. So many students, as I told you, not only in India, in everywhere, our students are there. And we are teaching from them. Every faculty, we are teaching from the result. Thank you, guys. It's a nice journey with you guys. 3 days. Excellent. Okay. Thank you for joining. Thank you. Thank you, Ravi. Thank you. Thank you. Thanks a lot. Thank you. I will share the notes once again. Thank you, Sai. Thank you. You will get the option. Uh, no, you can contact directly Naresh IT. Okay, you can contact directly Naresh IT. If you have any doubt or something, you can mail me. My mail ID is something like this. I'm writing my mail ID. If you have any doubt, you can send mail to me. But I am a faculty of Naresh IT, so I'm dealing the courses of Naresh IT. Especially we are dealing with placement program in Naresh IT. So that placement program means what? We are providing the job after your course completion. In course duration is 6 months, and in this 6 months we are going to deal so many courses. Okay, you can take demo classes. You can go to the Naresh IT official channel. You will get all the information. Yes, anything. You can talk to our counselor. They will guide you. Sairam. They will guide you. Sairam. You go to Naresh IT official channel. Ask for any kind of support. They will guide you. If you are interested for any course, take the demo class. Generally, 3, 4, 5 demo classes we are providing. Talk to faculty after first day. Talk what are the things they will teach you. Accordingly, you can take admission. Your choice. But this is our standard. This is Naresh IT standard. Every faculty you will get like that. This is the standard of Naresh IT. So thank you guys once again. I'm leaving the webinar and I'm sending the notes once again. Thank you. It was a great